STEM students. So this is lesson 3, but then again, I will just give 2 more examples before we proceed to our lesson 4. So this is my example. So let's have a slideshow. Okay. Find the Riemann sum for the function f of x is equals to e raised to x to the partition 0 and 3. So in our 0 and 3, our a there is our 0 and our b is 3. So let us solve it. Delta x is equals to b minus a over n, as you can remember. And 3 minus 0 over n, it is equals to 3 over n. So we already get our delta x. Now, to get our x of I, so as you can still remember, a plus delta x I. So therefore, our a is 0 plus delta x is 3 over n times I. So therefore, if we will add this one, we will get 3i over n. So when we have f of x of I, as you can see here in our given, our e is our f, and then you will just substitute the value of x to the given or to the answer of x of I. So therefore, we will just substitute it to 3i over n. So our f of x of I is equals to e raised to 3i over n. So to make it in the definite integral from 0 to 3, e raised to x dx, it is equals to the limit as n approaches positive infinity from I is equals to 1 to n delta x times f of x of I. So this is our formula. So when we will get the answer, we will get the limit as n approaches positive infinity from I equals 1 to n. So our delta x is 3 over n. This one. Okay? So multiply it to our f of x of I. So it will be this one. So it will be e raised to 3i over n. So therefore, this is our answer. We didn't get the answer or the final answer since we are getting the Riemann sum. Okay po? Okay. So this is your final answer, the Riemann sum. Okay? So next, let's proceed. Okay, because since I have the recorded one here, I will just make it small. Okay, because I cannot see this one. Okay, example 1. Compute the Riemann sum from I equals 1 to n f of x of I delta x. Okay, now let's slideshow. For the function f of x is equals to 1 over x on 1 and 6 with a regular partition into n equals to 5 subintervals and with x of I is equals to x of I. So but then as you can see, it also have already here a symbol. So therefore, let's see it. Okay, so in here we will make it an algebra. Okay, later on we will discuss it in the lower part in here. Okay, so as you can see, okay, note that a is equals to 1, b is equals to 6. Where did we get this? Here, a and b. Okay, n is given here, n equals 5. Therefore, when we get the delta x, which is b minus a over n, we'll just substitute it. It will be 6 minus 1 over 5. So it was 6 minus 1 is 5. Divided by 5 is 1. Okay. So our x of I, or our xi, is equals to a plus I times delta x, or it can be delta x times I. So it will be, our a is 1 plus I. Why I? It is because it will be 1 I. So therefore, it can be just I for each I. So as you can see here, we have a symbol. So let's make it like this. This is our f of x of I. It is equals to 1 plus 1 plus I for each I. Okay po. Okay, so in here, this is 1, this is 1, right? Our x here is 1 plus I, so this is, okay, you will just copy, okay, you will just copy, okay, so let's make it in an algebra, okay. The answer is intentionally not simplified for students to see the algebra. Okay, so as you can see, from I equals 1 to 5, it's a specific. F of x of I times delta x. So we will get already the algebra. So as you can see here, we have 5, right? So it means you will stop up to 5. Okay. So you will just start in 1 and then you will just substitute this 1. Okay. So let's try. 1. Okay, 1 plus 1, it's 2. Okay, next, plus 1. Okay, it will be 2 plus 1 is 3. Next, 3 plus 1, 4. 4 plus 1, 5. 5 plus 1 is 6. Okay, therefore, this is your algebra. Okay, to sum it up, the answer is 29 over 20. Or 1.45. Okay. It is because it is written here to see the algebra. Okay? But then, if we will just get the f of x of I, this is the answer. Okay? So now, I hope you understand this one. So we will proceed to our lesson 4. Okay. I make this a recorded lesson. It is because it's too long for us to take this class for just 30 minutes. Okay, so let's proceed to our lesson 4, definite integral of a function using fundamental theorem of calculus and substitution rule. Okay, here. Okay. In this module, we will be learning and solving definite integrals using fundamental theorem. But before that, let us have a short review on the rules for definite integrals. There are 11 rules and these are, okay, but then it is just given here our 1 2 3, okay, it's because 3a and 6a, that's therefore this is 11. Okay, so let's have the zero rule. As you can see here, it's a, right? So therefore it is 0. The value of a minus the value of a, it's 0. Next, for our reversing limits of integration rule, okay, just remember that b should be greater than a. Okay, again, b should be greater than a. So as you can see, a is here and b is here. Therefore, to make it a reciprocal or reverse, it should be negative. Okay, again, a is here and b is here. In our standard, b should be at the top and a should be in the bottom. Okay, so as you can see, it becomes negative for you to reverse it. Okay, next, the constant multiple rule. We already discussed this. You will just move the k outside the integral. Next, 3a special case. Oh, you will just move the negative sign to outside. Okay? Next, for our sum rule, we already discussed this one. You will just separate f of x to g of x. Also, in the difference rule, it should be f of x minus g of x. Okay? Next, for the domination rule, g of x should be greater than and equal to f of x on a and b. So therefore, you will just prolong it and you will just add the definite integral of b. from a to b g of x dx and greater than and equals to the definite integral from a to b f of x dx. Okay, you will just prolong this one. For our special case, f of x is greater than and equal to 0 on a and b. So therefore, the definite integral from a to b f of x dx is greater than and equals to 0. So here, we'll just make this f of x. Okay. Next, for our max min rule. So the min f of b minus a is less than and equal to the definite integral from a to b f of x dx, and it should be lesser than and equal to the maximum b minus a. This is just the roots, okay? Next, for our lower bound and for the upper bound. This is the lower bound. This is the upper bound. Okay? For the integral addition rule, our lower bound here is the definite integral from a to b f of x dx plus from b to c f of x dx. It is equals to the upper bound from a to c f of x dx. Again, you don't need to memorize this one. Baka sabihin nyo, ma'am, talking alien ka, ma'am. Hindi ko po namin maintindihan yung x, f of x, b of x, g of x, okay? So in here, you will just analyze it. You don't need to memorize it. As long as you know the process, it's fine. Okay, next, for our interval subtraction rule, our definite integral from b to c f of x dx, it is equals to the definite integral from a to c f of x dx minus the definite integral from a to b f of x dx. Okay? So let's have examples in further slides for you to understand this one. But then, we already discussed some of it. Okay? So as you can see, our definite integration, we define the definite integral of the function f of x with respect to x from a to b as, okay. So as you can see here, where is it? Where can I get my pen? Okay, it's fine. I cannot see the pen. Here. Okay. This one. Okay. We define the definite integral of the function f of x with respect to x from a to b as, okay, as our formula before, the definite integral from a to b f of x dx. So as you can see, f of x, this is our antiderivative. This one, it's just moved here. Okay, but then it is here. It is just written in the module, but then it should be here. Okay. Maybe they just put it like that. Okay. So, where f of x is the antiderivative of the small f of x, okay? So, we call a and b the lower and the upper limits of integration, respectively. Okay, the function being integrated f of x is called the integrand. So, we already discussed it before. So, remember, integration constant are not written in definite integrals since they always cancel in them. Oh, let's get it. As you can remember, we are always adding plus c. Alright? Plus c at the last part. So as you can see, why are we not getting plus c anymore? We are getting the antiderivative, right? We're getting the Riemann sum, we're getting this one. But then again, we don't have plus c anymore. So let's analyze and let's understand this one. So in the definite integral from a to b, f of x dx is equals to f of x. Okay, this is the vertical bar notation from a to b. So as you can see, we will be having f of b plus c, right? Minus f of a plus c. This one plus c again. Okay, we will now combine it. f of b plus c, just copy it, minus sign. F of a, it's minus f of a, right? And then minus sign to the positive c, so it should be minus. So positive c, negative c, so the rest is f of b minus f of a. So as you can still remember, this is our formula. Okay, the definite integral from a to b, f of x dx is equals to f of b minus f of a. Okay, next, for our the fundamental theorem, FTC part 2. Again, we are in the part 2. Okay, we still have 17 slides. Okay, so as you can see here, the theorem states that to evaluate the definite integral of a continuous function f from a to b, all we need to do is find the antiderivative f of f and calculate the number f of b minus f of a. So let's try this one. Let's evaluate the given, the definite integral from negative 1 to 3 x cubed plus 1 dx. Okay, this is our given. Next, this is our given. Okay. Next, what should we do if we are getting the antiderivative? We are adding plus 1. And this one will be your denominator, right? So therefore, this one is just this 1/4 shows you how to get this x raised to 4 over 4. So in here, 1/4 x 3 plus 1. Okay? It prolongs, but then it will just give you x raised to 4 over 4. So you will get x raised to 3 should be plus 1. And then plus x, y plus x. You will derive 1 dx. So it will be x. And then this is we have the vertical bar notation. So as you can see, if we have 1/4 x 3 plus 1, so you will put it as your denominator. So here, if we will not put this 1 times x raised to 4, it will be x raised to 4. 4 times 1, it will be 4. But then again, this will be a shorter way. Okay? So in here, you just put the x raised to 4 over 4 plus x in the shorter way. And then this is also a vertical bar notation in here. Okay? So as you can see here, you will just substitute the value of b and a. This is negative 1, as you can see here. You cannot see it. It's so small. Okay, next, you will just substitute it first at the value of b. It is because we get f of b minus f of a. Okay, so in here, so you will get 3 raised to 4 over 4 plus 3. You will just substitute the value of b minus the value of a. It will be negative 1 raised to 4 over 4 plus negative 1. So if you will make this 3 times 3 times 3 times 3, 4 threes, it will be 81 over 4 plus 3 minus negative 1 times negative 1 times negative 1 times negative 1, it will be 1 over 4 minus. It is because positive times negative is negative, minus 1. So therefore, we have 81 over 4 plus 3 minus 1/4. Negative times negative, it's positive. So therefore, 81 over 4 plus 3 minus 1/4 plus 1 is equals to 24. This is your answer. Okay? Let's make another example. Evaluate the definite integral from 2 to 6, t squared plus 1 dt. Since we use t as our variable, we use dt, not dx. Okay? So let's have this one. This is our given. Okay, next. 1/3 t2 plus 1. It is because 2 plus 1 is 3. And then it will be 1 times t raised to 3. It's the t cube. 3 times 1 is over 1, okay? So it is 3 plus t. Why? It is 1. dt, it's t plus t. And this is a vertical bar notation. Okay? So in here, we have here b and a. Okay. So you will just substitute the value of b, which is 6 cubed over 3 plus 6. Why do we get this one? It is because of f of b minus f of a. Okay. So in minus, you will just substitute it at the value of 2. 2 cubed over 3 plus 2. So therefore, as you substitute this one, let's make it 6 cubed is 216 over 3 plus 6 minus 2 cubed is 8 over 3 plus 2. So you will just simplify this one. 216 divided by 3 is 72 plus 6 minus sign, and then a third minus 2, since minus times positive, it's negative. So if you will sum this up, your answer is 73 and 1/3. Okay. I will just make it smaller again since I cannot see because of the recording. Let's skip this one. Okay, let's read this first. The function f of x equals x squared minus 4 over x minus 2 has a removable discontinuity on 0 and 3, so f is integrable, but FTC does not apply. We can, however, apply FTC through. This is our FTC, means fundamental theorem. Okay? Let's slideshow. Let's make it bigger. Okay. So we can, however, apply FTC through our given. We'll put it in here. It will be the definite integral from 0 to 3. Why? This is our A. This is your B. So therefore, you can do it as your own, in your own. You can do it in your own. Okay, here. Definite integral from 0 to 3. So we have there a given x squared minus 4 over x minus 2. This one. dx. Okay? So make it like this. Since, why we will make this like here? Square of binomials, right? So it will be definite integral from 0 to 3. It is because, as you can see, x minus 2 can also be a factor of x squared minus 4. Because the factors of x squared minus 4 is x plus 2 times x minus 2. So therefore, as you can see, we can cancel. Where's the pen? Here. X minus 2 and x minus 2. Okay? So you will cancel the like terms or the same terms. So therefore, you will just have the definite integral from 0 to 3, x plus 2 dx. Okay? So let's have this one. Okay. You have 1. You have plus 1. So it will be x squared over 2 plus 2x. Okay? So it will be x squared over 2 plus 2x over the vertical bar notation from 0 to 3. Okay? Let's have it. Excuse me. Masyado nang mahaba. It's already 25 minutes. Okay, let's continue. It will be, excuse me, it will be x squared over 2 plus 2x. So you will just substitute it to the value of b and a. So you will be having f of b minus f of a. So therefore, we will make a 3 squared over 2. It will be 9 over 2 plus 2 times 3 is 6 minus 0. Because 0, it will be 0 already. Why? It will be 0 squared over 2, right? So 9 squared plus 6, it will be 10.5. So therefore, your answer is 10.5. Okay, next. Review the basic integration from, I cannot see it again. It's because of the recording. Here. Review the basic integration formula. Let's have the constant rule first. Okay, again, this is the formula. It is better for you to know the process. Okay? It is because if you just know the formula and you do not know the process, you will just stuck in the formula. Constant rule. Our definite integral of d of x is equals to x plus c. This is already discussed last first lesson, if I'm not mistaken. Next, simple power rule. Uh, we already discussed this. X raised to n, it will be plus 1, and your exponent will also be your denominator plus c or n should not be equal to -1. It is because -1 plus 1 is 0. Next, general power rule. For our general power rule, u raised to n du over dx times dx is equals to the definite integral of u raised to n du is equals to the u raised to n plus 1 over n plus 1 plus c, where n should not be equals to -1. Okay, you just substitute. Okay, you just substitute this one. This is the given. Later on, we will use u. Okay. Next, simple log rule. We already discussed this one. The ln x plus c. General log rule. 1 over u du over dx times dx. So your answer will be the definite integral of 1 over u du is equals to ln u plus c. Already discussed this one. Simple exponent rule. E raised to x dx. E raised to x plus c. And general exponential rule. So therefore, it will be definite integral of e raised to u du over dx. So your answer will be the definite integral of e raised to u du is equals to e raised to u plus c. Talking alien na naman si ma. Okay, let's have an examples later on in the next slides. Okay? So you don't need to memorize this one as long as you know the process. Okay, also this one. It is just written in the module, but then again, I already gave you the definite integral or the derivatives, right? So it's here. It is written here in our table. So the definite integral of sine x dx is also the negative cosine x plus c. Okay. So you just check this one, but then again, you don't need to memorize everything. Because I told you to make you will make an index card. Okay? Okay, we already discussed this. This one. This one. Okay, this one we already discussed. Okay. This one also. And the trigonometric, we already discussed this. Okay. And then the rest. Okay. This is just additional. Okay, table of integrals. But then again, we already discussed this one. The 1 to 17. Okay, this is just written in our module. Again, it is just written in our module. All the topics, all the contents that is written in the PowerPoint, it's in the module. Okay. How to evaluate the definite integral? I cannot see again. Yeah. How do we evaluate the definite integrals of the definite integral of b from a to b f of x dx, where the substitution technique may be applied? Okay, we will use already the substitution. For you not to use us too long, but then I will not push you to do this if you are confused. Okay, it's fine if you will use our um, solution before. It is also fine if you will use this one, the substitution. It is because you will just use u as the letter, and you don't need to put always the x minus 2, x minus 2, x minus 2 up until the end. Okay? In the previous module, we were taught the substitution rule, which allows us to solve the given integral without having to perform tedious multiplication at all. That is, with y equals to x minus 2 or u equals x minus 2, we get. Okay, let's try it. Let's solve it. In our given, it is written here. The definite integral of x minus 2 raised to 54. This is the given. Next, for you not to write x minus 2 raised to 54 always, always and always, you will just use y. Okay, this one. So you will just use y. So it will be the definite integral of y raised to 54 dy. Why it is dy? It is because you use variable y. Next, what will happen? Why it should be 55? You will add plus 1. So it will be what? Y 55. 1 times y 55. Y raised to 55 is y over 55. Y raised to 55 over 55 also. Okay? Y, it is over 1. 1 times y raised to 55 is y raised to 55. Over 55 times 1, it's 55. Plus c. Next. You will just make it like this. 1 over 55 times x minus 2 raised to 55 plus c. Okay? It is because you will just substitute. What is our value of y? X minus 2 raised to 55. It is also fine if you will use x minus 2 raised to 55 over 55 plus c. It's also the same. Okay? Okay, we already use y here. Let's use u here. Okay? The definite integral of x minus 2 raised to 54 dx. It is equals to, okay, let's use u. Letter u. Our u here is x minus 2. Okay? So the definite integral of u raised to 54. So 1 over 55, u raised to 55. Where do we get the 1 over 55? 54 plus 1. So it will be like this. Okay, u raised to 55 over 55 plus c. So therefore, as you can see, we have 1 over 55 times x minus 2 raised to 55 plus c. It is just the same. So you see, it's just the same. We just use different letter or different variable. Okay? This is the substitution rule. It means you will just substitute it to the letter or to the variable so that you will not be confused to use x minus 2, x minus 2, x minus 2 up until the end. Okay? Next. Okay. To illustrate, to integrate the definite integral from 1 to 3 times x minus 2 raised to 54 dx, we first apply the substitution technique to the indefinite integral using substitution. Y equals x minus 2 over u equals x minus 2, and express the antiderivatives in terms of x. Okay, let's use this one. So our given is definite integral of x minus 2 raised to 54 dx. So it will be like this one. 1 over 55 times x minus 2 raised to 55 plus c. Okay, so we apply the FTOC using the original limits of integration x equals 1 and x equals 3. So let's have the upper limit first. X minus 2 is equals to 3 minus 2 equals to 1. Okay. Okay. So as you can see there, in here, we have the given x equals 1 and x equals 3. So in our B, our B is 3. This is our B, and this is our A. Okay. X minus 2 equals to 3. Why? It should be 3 minus 2. So therefore, our answer is 1. In here, it is 1 minus 2. It's negative 1. Okay, this one. Next. Our formula, the definite integral from a to b, f of x dx is equals to the antiderivative of f of x from a to b is equals to f of b minus f of a. So as you can see, we already have here our b and a. So the definite integral from 1 to 3, so x minus 2 raised to 54 dx is equals to 1 over 55 x minus 2 raised to 55 from 1 to 3. Okay, our next rule or our next step here is to substitute it to f of b minus f of a. Okay, next. Our f of b. What is our f of b? We already use the solve upper limit and lower limit. Okay, again, we will already use the upper limit and the lower limit. So as you can see here, we already use 1 and negative 1. 1 over 55, 1 raised to 55 minus 1 over 55 times negative 1 over 50 raised to 55. So therefore, our 1 over 55 plus 1 over 55 is 2 over 55. We already use here the FTOC, wherein we already solved the upper limit b and the lower limit a. Note that for definite integrals, we can omit the constant of integration c in the antiderivative, since this will cancel when we evaluate the limits of integration. As we discussed earlier, we will not use c anymore, since in here, the f of b minus f of a, we already canceled plus c, since plus c minus c is 0. Okay? So it will be 2 over 55. Okay? Okay, going back in the example earlier, okay, maybe you will be confused, ma'am. Where did we get 1 and 3? Okay, as you can see here, your given is just x minus 2 raised to 54, right? So in the next slide, there are given, and these are the x equals 1 and x equals to 3. Therefore, you need to substitute the two x's to the given x minus 2. Therefore, we get the 1 and the negative 1. We have the upper limit and the lower limit. Our upper limit is the b our lower limit is the a, right? So therefore, you will use that in f of b minus f of a should be 1 and negative 1. Okay? Okay, as I can see, it's already 40 minutes. Okay, let me drink water first. Okay, to go back, let's have the method 1. Okay. I cannot next it. It is stuck here. It is to illustrate, to integrate the definite integral from 1 to 3 x minus 2 raised to 54 dx. As you can still remember, this is the given earlier. Okay. This is also the given earlier. Okay? But then again, we will just check it in our method 1. Okay? For our method 1, let us use the same example, x minus 2 raised to 54 dx. It is equals to 1 over 55, x minus 2 raised to 55 plus c. Okay? So, ma'am, bakit po may plus c dyan? Di ba po, sabi po natin, wala pong plus c? Okay. Tignan po natin dito. Okay? Kasi nga po, dito sa may plus c na to, hindi pa natin nagagamit yung ating f of b minus f of a, right? Kasi dito po sa ating f of b minus f of a, dito natin na i-consider yung plus c minus c. I-discuss natin kanina. So, let us apply it in here. Using the original limits of integration, we have the given x equals 1 and x equals 3. So we get two x's here. So we have here a and b, since we have two given x's. So in our upper limit, we have b, right? In our upper limit, that is the value of b. And for our lower limit, that is the value of a. So as you can see, we have x minus 2 also, and then we will be using here b minus 2. So b minus 2 is 3 minus 2, it is equals to 1. X minus 2, it is 1 minus 2, so it will be negative 1. Okay, we already get the upper limit and the lower limit. So as you can see, we have another set of b and a. Okay, later on we will see where do we need to use it. Okay, for our formula, we have here the definite integral from a to b, f of x dx. It is equals to the antiderivative of f of x with the vertical bar notation, as you can see, from a to b. So it is equals to f of b minus f of a. Okay, so dito po, ito ang ating given. Okay, ating given, ito po yan, ito. Yan. Okay. And then, you already have your answer here. It is just 1 over 55, x minus 2 raised to 55. The vertical bar notation, 3 and 1. Or from 1 to 3. So, dito po natin nagamit ang ating bagong upper limit and lower limit. Dito na to sa ating substitution for the value of f of b minus f of a. So, kung titignan po natin, it will be 1 over 55 times 1 raised to 55. So, it is equals to 1 over 55. And then, 1 over 55 times negative 1 raised to 55. So, it's negative and the answer is also negative here. So, it will be positive. So, 1 over 55. 1 over 55 plus 1 over 55. Same denominator, therefore your answer is 2 over 55. See, they are the same. So let us proceed to the method 2. again, let us proceed to our method 2. We already have here the same given. The definite integral from 1 to 3, x minus 2 raised to 54 dx. So let's apply it to the substitution technique. So we let u as x minus 2. So du is equals to dx. So kanina, we have the lower limit and the upper limit. So as you can see, x equals 1. So it will be u equals 1 minus 2 is negative 1 for our lower limit. It is just the same as here. Okay. Next, x equals 3 equals u equals 3 minus 2. It is equals to 1. Okay, for our upper limit, this one. Okay, so when we apply FTOC to the definite integrable involving the new variable u yielding, as you can see here, we have the same given. But then, in our method 2, FTOC, we already use the new value of our B and A, which are the 1 and then negative 1. This is our B and this is our A. And also for the substitution technique, we will use U and it will be du. Okay, so it will be the definite integral from negative 1 to 1 u raised to 54 du. So as you can see, what will happen? Antiderivative, so 54 plus 1 over 55. Therefore, it will be u 54 plus 1 over 54 plus 1. It is this one. U raised to 55 over 55. This is the vertical bar notation from negative 1 to 1. So therefore, what will we do next? We will substitute it to the B and A. We will substitute it to the value of f of B minus f of A. Okay. So it will be like this. You will substitute it. 1 raised to 55 over 55 minus negative 1 raised to 55 over 55. So as you can see, these are both negative, or minus side is negative. So we will get plus. And then 1 raised to 55 over 55 plus 1 raised to 55 over 55. The answer is 2 over 55. So as you can see, we use method 1 and method 2, but then again, we get the same answer. It depends to you on where you will be solving easier, which is wherein you can use method 1 and method 2. Okay, let us summarize it. Again, this is just a formula. You don't need to memorize everything that is written here. Okay, so in applying the substitution technique of integration to the definite integral from a to b, f of x dx, so ito po yan, is replaced in terms of u or y. It depends sa inyo kung gagamit kayo ng u or y sa function ng x. So, if we say u, that is f of x. Ginagamit na po natin ang u as the substitution of f of x. So, ang ating du naman, ito na po yung antiderivative ng ating u. So, it will be f prime x dx. So, the antiderivative say that capital F, or the antiderivative f u, is just expressed as the function of u. Okay, and this is also evaluated with the original bounds x equals a and x equals b. The new value of a and b. Okay, in the second method, we proceed with the substitution as above and as computed, or as above, and the new bounds are computed to the new same equation used to perform the substitution. If u is equals to f of x and the new bounds are u is equals to f of a and u is equals to f of b, right? We are using f of b and f of a, right? So in here, again, you don't need to memorize the formula as long as you know where you will get it ang pinaka-importanting formula lang po na dapat alam po ninyo, yung B minus A over N, yung F of B minus F of A, ano yung mga step 1, step 2, step 3, yun po ang dapat nyong malaman at dapat nyong kabisaduhin. Ano yung mga ginagamit per step. Okay? In the definite integral is now expressed as, this is just a formula, the definite integral from a to b, f of x, f prime x dx is equals to the definite integral of f of a, from f of a to f of b, fu dy. This is known as the substitution rule for definite integrals. Don't you worry, we have examples to this one. Okay? So in here, as you can see, we have compute the definite integral from 0 to 2 x minus 1 cubed dx. This is our example. Okay? So, ang sabi po kanina, ang ating f of x, ang ating u. Tama? So, ito siya. Yan. Ano naman ang sinabing du? The derivative of what? The derivative of u. Okay, again, the derivative. Okay, the derivative of f or u. Okay, again, the derivative po. Derivative. Again, the derivative. Since in here, it is small letter, and then in here, the antiderivative. Okay, let us use this one. dx equals 1/2 du. Ma'am, saan natin nakuha iyon? So, as you can see, du is equals to du dx. So, du is equals to 2 dx. So, du over 2 also. So, as you can see here, you will cancel 2 and 2. Why? 2 divided by 2 is 1. So, du over 2 is equals to dx. Therefore, our dx is 1/2 du. Okay? So, let's evaluate the definite integral we have. So, as you can see here in the definite integral of 2x minus 1 cubed dx, it is equals to the definite integral of u cubed times 1/2 du. Saan natin nakuha yung ating u? Dito po sa ating 2x minus 1. Ito po yan, ang ating f of x. Saan natin nakuha ang 1/2 du? Dito po sa ating na-solve na 1/2 du. Okay? So, dito naman po, ano nang susunod natin gagawin? Ang ginagawa po natin dito, yung substitution. Okay? So, dito, kung makikita po ninyo, meron tayong 1/2 du. Yung du, matitira lang yan sa dulo. Ilipat natin yung 1/2 dito. Step by step muna po tayo para lang maintindihan po ninyo, ha? 1/2, i-proceed lang po natin dito. Okay? So, 1/2. Andito na siya sa 1/2. Ngayon, ilalabas din natin siya. Diba? Sabi natin, pagka po may value sa harap po ng ating u cube, o sa harap po ng ating f of x, ilalabas po natin. So, it will be 1/2 the definite integral of u cube du. So, ano po ang gagawin natin? Ito ay nakahiwalay. Ito ay nakalabas. So, 1/2 times ito ay u cube plus 1. So, over 4. So, u raised to 4 over 4 plus c. Okay. Next, 1 times u raised to 4. It is u raised to over 2 times 4 is 8. So, if we will just substitute it with the value of at our u, it will be 2x minus 1 to the 4th power over 8 plus c. Okay? Ma'am, bakit po may plus na naman? Again, hindi pa po dito nagtatapos ang ating solving. So, we will proceed to the next part. Okay. Sana nauunawaan po ninyo kung saan nakuha. Pwede po natin itong ang ilagay. Pwede na naman ito. Okay? So by our FTOC, as you can see here, we have the same example. Again, this is just a continuation. It will be smaller if I put it all here. Therefore, we have here the definite integral from 0 to 2 x minus 1 cubed dx here. Yan. Same siya kanina. Yan. And then, our final answer is 182 x minus 1 raised to 4. And our B and A is 2 and 0. So, we use the vertical bar notation. So, in here, 182, what is our value of x? We will use the B and the A. So, as you can see, f of B minus f of A, right? So, therefore, we will just substitute it with the value of B and A. Okay, so it will be 182 times 2 minus 1 raised to 4 minus 182 times 0 minus 1 raised to 4. So in the next step, we have 18 times 3 raised to 4. Where do we get this 3? 2 times 2, 4 minus 1, 3. Okay, so 18 times 3 raised to 4 minus 18. 2 times 0, it's 0 minus 1, it's negative 1 raised to 4. Therefore, we will get 18 minus or negative 1 raised to 4. Okay, so as you can see, 18 times 3 raised to 4, it's 10.125. Then copy the symbol or the operation minus. 18 times negative 1 raised to 4, it is 0.125. Therefore, 10.125 minus 0.125 is equals to 10. So that is your answer. Okay, let us proceed to our method 2. Let u equals 2x minus 1 and let du equals to 2 dx. Okay? So hence, dx is equals to 1/2 du. The bounds are then transformed as follows. Okay, so if we will have, if x equals to 0, then if x is equals to 2, then what will happen next? This is our given, right? 2x minus 1. Okay? 2x minus 1. So the first one, we will use it as 2 times 0 minus 1, it is equals to negative 1. 2 times 2 minus 1, it is 3. Therefore, this is the value of our A and B. Okay, so let's have the substitution yields the transformed definite integral. We have the definite integral from negative 1 to 3. So we have the u cubed times 1/2 du. Okay, so as you can see here, we have the dx of 1/2 du. Ayun po ang ating gagamitin. Kasi nga po, ang kaninang given sa kanina po ay du is equals to 2 dx. O, paano gagawin natin? Di-divide natin sa 2 para makuha natin ang dx. So, it will be 1/2 du equals to dx. So, it will be like this one. Okay? So, now, let's now proceed. So, this is our... You cannot see. Okay. So, this is it. Now, let's evaluate the above definite integral. So, as you can see, we will evaluate it. So, this is our given. So, again, ang sabi po natin, yung 1/2. Okay, pagka po merong 1/2 na ganito or may value, ilalagay po natin sa unahan ng u cube. Or in short, lalagay na po natin siya sa labas. Okay, so magiging ganyan po siya. Na-move po siya dito. Yan. Tapos ngayon, na-move na siya sa labas. Again, yung value po ay inilalabas natin. Inihiwalay po natin sa f of x natin or yung ating u. Okay? So now, we will have 1/2. So next, the definite integral of 3 from -1 to 3 u cubed times du. Ano po ang gagawin natin dito? It will be plus 1/4. Or 1/2 times 1/4 u raised to 4. Pwede rin naman po ito. Okay? Pwede rin naman siyang pong ganire. Wait lang po. 1/2 u4 over 4. Pwede rin siyang ganyan. Or pwede rin po siyang ganito. Yan. Yung vertical bar notation na sa atin yung from -1 to 3. So, in here, we will have 1/8. Saan natin nakuha yung 1/8? 1 times 1, 1. 2 times 4, it's 1/8. So, ngayon, gagawin na po natin yung ating u raised to 4. Ano po ang ating u? So, ngayon, tingnan natin. Ito po ang 1/8. Ito po ay 3 raised to 4 minus -1 raised to 4. Again, kung kanina po natatandaan po ninyo, ito yung kanina. Ito. Yan. Yung may 1 over 55, 1 raised to 55 minus 1 over 55 times -1 raised to 55. Kung titingnan po ninyo dito, naka-automatic na isang 1/8 lang. Bakit isang 1/8 lang ang ginamit? Kasi kung titignan ninyo, pwede po natin siyang isulat sa katulad kanina. It will be 1/8 times 3 raised to 4 minus 1/8 -1 raised to 4. So, in short, you can use this one, but then it's also like this. Since we have bracket here, it is like you multiply 1/8 here and you multiply 1/8 there. It's just the shorter term, okay? So, but then again, this is our b and this is our a, the f of b and our f of a. Okay? So, now, as you put 1/8 and then 3 raised to 4 in your calculator, it will be 3 raised to 4, it's 81. -1 raised to 4, 1, it's -1. So 1/8, you will just copy 1/8. And then 81 minus 1, it's 80. So 1/8 times 80, it's 10. So therefore, the answer here is 10. Okay? Again, you can use this one like 1 over 55 earlier. And you can also use 1/8 like this since it has bracket. Okay? Let us compute this, the definite integral of -2 from -2 to -1, square root of 2 minus 7x. Okay, for our solution, let y, again, ngayon, ang ginamit po ay y, hindi u. Let y is equals to 2 minus 7x. So, it follows that dy is equals to -7 dx. Right? The only one that you can derive here is a -7x, which is -7 dx. Now, how can you get -1 over 7 dy? It's -7. You will divide it to -7 both sides to cancel -7 here, and you will get that dx is equals to -1 over 7 dy. Okay, for the transformed bounds, let's have x equals -2, then x equals -1. So as you can see, we will use here y. Y is 2 minus -7x. So y equals 2 minus 7, -7 times -2 is equals to 16. -7 times -2, it is 14. And then it will also be positive. So it will plus 2, it's 16. 2. -7 times -1, it's positive 7. And then you will add 2, so it will be 9. So again, this is your A and this is your B. Okay. So now, let us proceed for our given. So our given is the definite integral from 16 to 9, the square root of y. So it will be times -1 over 7 dy. So as you can see, if we will put it in here, in our equation. So it will be the definite integral from 16 to 9 y raised to 1 half, since our square root is raised to 1 half, times negative 1 over 7 dy. Okay? So in here, as you can see, it will be negative 1 over 7. Di ba po? Sabi natin, ilalabas natin yung may value. Okay? So, negative 1 over 7, ito siya. Definite integral from 16 to 9, y raised to 1 half dy. Or, positive 1, 7, the definite integral from 9 to 16, y raised to 1 half dy. As you can remember earlier, we cannot put the a as higher, right? It should be b as the higher. So as you can see, it will be like this. Negative 1, 7. It will be negative 1, 7. It will be negative, right? Kasi pag nagpapalit po sila, magiging negative yan. And then y raised to 1 half dy. So negative times negative, it's positive. Therefore, we have positive 1, 7 here and positive 16 and 9 here. Okay? Again, you should use A as lower than B. Okay? So hence, we have the definite integral from negative 2 to negative 1. The square root of 2 minus 7x dx. Okay? Ito na po yung given kanina. Ito yung given kanina. And then it was changed to 1 over 7. The definite integral from 9 to 16. Y raised to 1 half dy. So it's like this. Now, you will be putting 1 over 7 times 2/3 y raised to 3 halves. Natin to nakuha. Di ba po, tayo ay mag-a-add dito ng 1, right? And then, your exponent will also be your denominator. So, 1 half plus 1, it is 3 halves. Okay? It is 3 over 2. Therefore, as you can see, y raised to 3 over 2. And then now, if you can still remember our rule, if you will be you will have a denominator or fraction denominator, you will multiply it to the reciprocal of the fraction. So as you can see, we copy 1 7 and then times 2/3. The reciprocal of 3 halves is 2/3. Y raised to 3 over 2 and from 9 to 16. Again, we already used the vertical bar notation. 1 times 2, 1 7, rather 1 7 times 2/3, it's 2 over 21. Okay, or 1 times 2, it's 2 times 7 times 3, it's 21. And then, as you can see, y 3 over 2. Our y earlier, it is 16 and 9. And then again, it is already switched in the given. This is already our b and this is our a. This is our b and this is our a. So as you can see, it is f of b minus f of a. So 2 over 21 times f of b minus f of a. So as you can see, 16 raised to 3 halves minus 9 raised to 3 halves. So if you will input this in your calculator, it will be 64 minus 27. 64 minus 27 is 37. So 2 over 21 times 37, it is 74 over 21. So this is your final answer. Okay, so that's the end of our lesson 4. And I will be posting this in our YouTube. So that is the end of our second quarter. Thank you so much.